recording again. I have to start with it, no worries. Alright, I have started the recording again, and here is the code. So if a single methods need to be called, then we can directly use two colon. Alright, but it can be used only if there is no parameters to pass, right? So till here, okay, just give me 1 second. Clear till now?
Yeah.
Alright. So what we are doing, we are casting vote, right? And eventually after casting votes, all the votes, and then let's print total votes casted, and then voting machine, and get total vote cast, right? If we run this again, the thing is 0. Okay, this also. All right, so why get vote, okay, my bad. Okay, voting machine, which voting machine we are using? We are using multi-threading synchronized. Okay, no, this we don't want to use this voting machine. All right, let's remove this. And okay, voter machine, we need voting machine. Cool. All right, voting machine, and then voting machine, and then run it again. And voting machine get total votes. Let's run this now. Okay, again 0 vote casted. Why cast vote? Okay, yes. Okay, we need to wait, right? Make sure thread dot wait, thread dot current, not thread dot sleep, and 2 seconds is enough, and then run it. So after 2 seconds, total casted 50, right? But we have already seen if we increase this number to way too much, then there will be a discrepancy somewhere down the road, right? So how we can write this thing in a normal, so that all threads should wait in a line? We can write a simple by adding a lock. And how we can use lock? There are multiple classes for the locks, but the most used class is reentrant lock. So what we are going to do is use a class with the name reentrant lock, and we need to know what is a lock also, private, and we need to make the lock final. Why? If someone changed the lock, then what's the mean, right? We should, whatever lock I have put, the lock should be that same lock, right? If someone is able to change the lock, then the lock has no sense, right? If you put a lock in the door, you have the key, then you will be able to open it, right? If someone is able to change the lock, then what's the use case of your lock? So it should be final also. And lock, again, lock will be a interface, right? And then it will have many methods, right? So what class we are going to use is reentrant lock. All right, static. Okay, in return type required. Why return type required? Private final. Okay, my bad. Okay, cool. So variable was not there. Cool. So we have the lock, and how to use this lock. Now just simply lock, right? And then lock dot unlock. That's it. Okay, unlock and unreachable. Okay, I'm returning the value. Okay, so okay, not here. Okay, my bad. The code should not be here, and it should be in the cast vote, right? Code visible. So if I have any lines before this sys out, thread 50 threads are there, right? Thread dot current thread dot get name, right? And reach to cast vote at, and then system dot current milliseconds divided by 1000, and this and this. Cool. So now what will happen, that all threads will come, but it will, okay, what's happening with this? Okay, so all thread will come, but as soon as line number 14, if they will reach at line number 14, they require lock to move forward. So this, at this line, they're going to wait, and then let's suppose the thread 1 comes here first and he is able to get the lock, then he will increase the value and then he will unlock it, and after, as soon as he unlocks, the another thread T2 can get the thread, sorry, lock, and he will be able to execute line number 15. It becomes way too easy again now, right?
Yeah.
No need to know how the synchronize working, how this working. Okay, locking here, unlocking here, that's the simple thing. So see, the task is of single line, so it happens way too quick, way too early. But if we can write more line over here, so let's suppose same line, let's copy, and okay, my bad, let's remove this, is inside, is to cast, has lock, and will cast vote. All right, but the thing is, I want it to cast vote and take at least 10 seconds, okay, at least 5 seconds to cast a vote. So now we will see that all threads will come over here, all the 50 threads will come over here, but lock will get, only one will get the lock. If we run this now, okay, my bad, let's remove this. Do I need to remove one more? Okay, we need to check this now. Oh, it's starting over here, and just okay, sys out, inside sys out. Okay, now it's fine. Cool, let's run this now. So we'll see. Oh, the wait, how many threads? 50 threads should have come. Let's run this again. Okay, all right, 2-second wait is there, right? Only okay, let's add this to unlimited. Now also, why only few threads coming? Okay, see, okay, cool. See, okay, let me close all two things and let me run it again. Now you will see, because I'm using the completable future, I don't need to work with the size of thread pool, right? It has already decided, using my code, at how many thread it should use to maximize it. So it has chosen the 7 maximum threads, and see, worker has lock, and then it's casting vote, worker has lock in casting vote, right? So it's going to be in a sequential manner, as we were doing with the synchronized keyword. Visible?
Okay.
So now if a fresher comes and use the completable future along with these things lock, then he don't need to know that okay, something like the connection pool is there, sorry, connection, not this, is thread pool is there, and then there are algorithms to find out what's the maximum number of threads that can be helpful for us. Because if we have 10,000 tasks, so it's not the case that 10,000 tasks, 10,000 thread will be the best case scenario for us. Because if you have the 10,000 tasks, if you have 10,000 tasks and you create 10,000 threads, then your thread will consume all the RAM, and then you will have way too less RAM to work with. So your 10,000 threads will work way too slow, because they will be fighting for a limited RAM that is available left in the system.
Acha, okay.
So this is not the case that the maximum number of thread will provide you the maximum least amount of latency. So that's the case. So we need to find a minimum or the maximum amount. Okay, so the maximum amount of the threads that we want, which comes with an algorithm, or we need to find out using something. But if you're a fresher, don't know this, you use completable future, then it will be automatically considered. You don't need to put anything, need to know anything, right? And the locks also, you can directly use, okay, this is the part where You can just right click come here. Okay, this is the part only from here to here. This is the part which should be done in a synchronized manner. Let's lock here and unlock here. That's it. That's the beauty of the locks. And this thing we cannot do it, right, with the synchronized keyword. And this is the one thing, right? Another thing with the lock that is good, if I, again, this is the reentrant lock, right? What's the use case of reentrant lock? If you get inside, if I write password inside it again, now what I have done, a recursion, right? It's a recursion. I will come here, I
Yeah.
will unlock
Yeah.
it, and then I will again go inside and lock it, right? But it will be I mean, I will unlock it, then I will lock it. But over here, if I put, then what will happen? It will lock, then again it will come here, right, to cast vote, right? And then here there should be a deadlock, right? Because this method has a lock already. How can it can again get a lock, right?
Okay.
But the deadlock will not happen because this is a reentrant lock. So that means if you have a lock already, then you can have another lock as well. But the thing is, if you want to make sure that another thread will be able to use it, then you have to unlock it the same number of time that you have locked it. That's the case with the reentrant lock. So if you use the reentrant lock, there is less chance of deadlock created by the same thread, because the same thread has a
Okay.
resource and again wants a resource, so that thing happens less. So if you are a fresher, you again don't need to know a lot of things about the deadlocks also, because if a single thread is creating again the multiple trying to access the lock of a resource again and again, then that thing can be handled by the reentrant lock. So eventually at the end of the time, Java has made this multi-threading way too easy for a fresher also to work with. And that's not the only beauty of this lock. What's the biggest drawback, and I hate it with the synchronized keyword. I mean, I hated it for a lot of reasons, but what I hate it is for it cannot work with different methods. Let, for example, I have to take a lock here, right? I have to take a lock for this method. And let's suppose if I want to take lock of only few lines, right? Let's suppose only here I want a lock, right? And till here only I have a synchronized block also, right? To mimic this, you can say, right, that this thing we can also mimic with the synchronized block, right?
Yeah.
So what's the new thing with the synchron lock, right? So everyone is so excited about. The thing is, now the synchronized block, okay, line 1 and sys out line 2, and let's duplicate it, and okay, now I have to update this thing 4 5 6 7 8, right? I can unlock this thing in another method. I don't synchronize keyword you have to use inside the same method, right? Synchronize block if you use,
Acha.
I can unlock in another method as well. Another thing, no class, no method has to be synchronized. Cool, visible. It's on me where it can be locked and can be unlocked. It's on me. All right.
Yeah. Okay. Okay.
This is the first thing, right? But it has multiple things that we can use. Like the completable future, it also comes with a lot of things. Now let's see. Okay, interview synchronize method. Okay, where we have written this code. Okay, locks. Okay, yes, cool, great. So voting machine. So it's lock. Okay, so this is a lock. Let's check another example. So we need to put it inside a package. Basic, and what we have checked over here, locking and unlocking different package, locking and unlocking, and we can put this example inside this. Okay, let's create one another package first. So wait for a number of 10 seconds. Okay, cool. So create a package. basics lock functionality. All right, so I can move. Okay, why it's not moving? Okay, all right, so now we will see another things of the lock. Okay, so what we'll see, what's the bad thing with it? Okay, again, lock functionality, let's change it and call it wait and sec for lock. Another drawback of the synchronize, let's work with the synchronize keyword. Okay, let's directly write for the lock site runner and psvm. Let's suppose we have an object, we have a class. Let's suppose resource class, we have resource, right? And in resource public void get access, I want to get access of the resource, right? So over here I will use the lock, obviously lock equals to new reentrant lock. So now what will happen, let's suppose if I access to the lock, try, if not try, okay, my bad, over here this thing should be here. Let's just say that if I have a lock, then thread.sleep and 2000 seconds, right? 2 seconds. So let's say that 10-second work is there. So after 10 seconds sneaky throws. So lock and lock.unlock, right? B2Z. So over here current thread.name plus, okay, came to get access of the resource. But what going to happen when it try to come with the resource, that only one will get the resource, right? So I'm going to copy paste it again and then get lock and start processing. Okay, let's remove this and eventually it will complete the processing. Cool. And let's create a resource. Let's go to the runner and resource equals to new resource, a single resource we have, and for int I equals to 0, I less than, let's create only few threads, let's create only 4 threads, I plus plus, because our thread is of heavy task, right? 10-second task. So not this, what we are going to do is completable future that run async, and we need a task, and the task is to call a resource method, and that is get access. All right, visible, clear to know? And because the single task is of, let's write undefined seconds wait sneaky throws. Visible? We are doing nothing, just a resource. We are calling the method of a resource, and what will happen, a thread will try to get the resource, and as soon as thread will get the resource, okay, every thread will come at this line number 15, but line number 17 will be executed by a single thread, and that thread will wait for 10 seconds. Cool. After 10 seconds another thread will get the resource, right? Visible?
Yeah.
Okay, let's run the code now. Okay, see, came to access 4 threads, 4 workers, right? But one worker gets the lock and start processing, and now later on after 10 seconds another worker will get the lock and start processing, right? but till now 20 second has been passed, right? Is it correct? But the thing is, if I'll keep if my use case is in such a way that I don't want to wait for n number of seconds. Let's suppose if you are dealing with an order, if you are able to book that order within 10 seconds or max 20 seconds, then it's cool. Otherwise, you should not wait for longer than 5 to 10 seconds, right? In the payment gateway, if I'm waiting, I worked in the payment gateway also, so in the payment stream. So in the payment gateway, if you cannot provide payment response in 20 to 30 seconds, right? So, and something has broken at your part, if the payment gateway is not providing response to your team, then it's a different thing. Then you should do something else. You should at least let the user know that okay, the payment is not confirmed. If we have not received any confirmation from the payment gateway or your bank, so as soon as we get some information, the order status will get updated, else you can directly contact your bank. This is how you also get, right, in the real time scenario. In some of the cases, if money is debited, sometimes money will be debited from your end, but the payment gateway informed the company that okay, we are not able to process your payment. So you show the user that okay, your order has been declined because the payment has not been gone through. So but if your amount has been deducted, then you will get that amount in the X number of days time. So that's how the thing goes, right? But you don't let your customer wait for 5 to 10 minutes, right, just for the payments status response, right? You make him free after 10 seconds, 20 seconds, depending on your company policy. That's what's happened to you also, right? If you have used anything. I'm audible?
Yeah. Yeah. Yeah.
So these tasks are high priority tasks. They should not wait for more than 20 seconds. They should write in such a way that each task should not wait for more than 10 seconds. So this is the way our requirement is. I should not let my user wait more than, let's suppose, 5 seconds, right? So how can I do it, right? In the synchronize keyword, if I use the synchronize keyword, then I have no access, right? They will start waiting and they will keep on waiting until they get the resource, right? Even if it's hours, right? I'm audible?
Yeah. Yeah.
And over here, the way we have written the code, that thing will happen with this code as well that we have written, right? But we can modify the resource. Every class has waited for 10 seconds, right? Every worker has waited for 10 seconds, but the maximum we want to wait is 20 seconds. Let's make it 21 seconds, so at least 2 threads will get processed. So I will not lock a lock directly. What I will going to do, I'll say lock dot try lock. If try lock, what try lock do, try lock just say that if I'm able to get lock, right, then I can work with it, right? Otherwise I can leave it. So if I get the lock, then cool. If I'm unable to get the lock, then I'll just print sysout and this unable to get lock, hence not processing the task. Cool. So what will happen now in this case, any one thread will get the lock, right, and the other thread will not process the task. Let's run this again. So see, worker 1 came, get the lock, right, and start processing. Worker 2 came to access the resource, and worker 2 unable to get the resource, hence not processing. Worker 3 to access the resource, unable to get the resource, not processing, right? Visible?
Yeah.
So now my other threads are not working, but the thing is that should not be the case, right? We have the 10 seconds window. So let's say we can wait for 20 seconds and 2000, 20,000 and 0, 0. Okay. Time unit seconds. So the thing is, I'm saying that I can wait for 20 seconds, right? Let's make it 21. So at least 2 threads will go through it, right? So run it again now. So now 4 threads come, but worker 1 gets a resource, right? So after 10 seconds, another thread will get the resource, and after it, okay, see, worker 2 get the resource, right?
Okay.
Okay, and after 20, okay, after 10 seconds, another one will get, okay, worker 3 will also get the resource, right? but 4 is unable to get the resource. So from 0 to 10 seconds, worker 1 get the resource, right? And then from 11 second to 20 second, worker 2 get the resource, right? And after 21 second, worker 3 get the resource, right? And after 27 second was a time limit, so our 4 worker does not get the resource. So this thing was, we did not had this thing with our synchronized keyword, right? I'm audible?
Okay. Okay.
And now the thing is, over here you can see that the worker 1, 2, 3, 4 come, right, in this sequence. 1 worker, 2 worker, 3 worker, 4 worker, right? Okay, and it get the lock also in the same manner, right? But it does not, it's not guaranteed, right, that they will get the lock in the same manner. It depends on the thread scheduler, right?
Yeah.
Okay, so now is there a way that I can make sure that FCFS is being followed? Obviously you don't know right now, but cool, there is a way. So now what I can do, okay, let's not write anything, so let's just put over here. So reentrant log has a constructor, right? It has a overloaded constructor which says that, okay, is synchronization should be fair or not. What does it mean by fair? It should use the fair locking ordering policy. And what is the fair locking ordering policy? That it will try to follow, right? It's not guarantee for the fairness, but it will try to follow fair ordering policy. And what is the fair ordering policy? Is FCFS. So if we try to run multiple times, there might be a chance worker 3 will get first the lock before the worker 2. But if we make the reentrant lock true, then it will make sure that it will follow the FCFS, right? So
Okay.
that's another use case of locks, right?
Okay.
Now
Okay.
the thing, we know about the thread dot interrupt, right?
Yeah.
So can a thread be interrupted? Is it possible to interrupt a thread while it is in waiting state? Is it possible? Hello, I'm audible?
No,
Okay, in which state we can interrupt a thread?
in runnable state.
And if it's sleeping?
Sleeping.
Okay, wait, see,
Exception.
that's why, come again? Okay, if we interrupt, then exception will be there only. I am interrupting to invoke an exception. All right, no worries. Let's go back and see that example again. Okay, where is the example? Okay, we have got that, right? It should be in the thread old thread dot sleep. Okay, it should be somewhere throw interrupted. Okay, thread dot interrupt. All right, interrupt yourself runner. Okay, we have covered a lot of interview questions of this thing, right? All right, cool. So let's write another interview questions because we haven't learned completely. Okay, I was trying to interrupt on this one, right? These all examples are good examples of the thread for interruption. Thread task. Okay, great. We can write this way. All right. So wait. Okay, interrupting. We have covered this thing, but no worries. Interrupting thread at different states. Runner. So I have a thread. I have a task. Runnable task equals to, okay, not new. So let's suppose we have the task, and inside the task I want to make sure that, okay, let's say it's processing right now, right? You said it, okay, nothing will happen if it's not processing. So for int I equals to 0, I less than integer dot max value and I plus plus, and what I want to do is I want to perform an operation hard enough to take some time. So I want integer max into integer max, and that's it. Okay, I don't want to print it also. I just want to make sure that my task is running, and long random equals to, and I'm not even using random, so processing cool. And while the task is being processed, thread equals to new thread dot start, and this is going to take some time, right? Because this is a little bit heavy operation from the normal ones, and I'm trying to run it 2 billion times, more than 2 billion times. So thread dot start, I have started it. Let's wait for 100 milliseconds. Okay, and no, not wait for 100 milliseconds, it's already it will take 100 milliseconds at least. So thread dot interrupt. All right, what will happen if I try to interrupt it? Okay, let me just this out also. Interrupting thread now. What will happen if I do it now, if I run it? Okay, I think I have interrupted way too early. Okay, so let's leave this. Okay, thread dot start. Thread dot start, and I have put this thing in here. Long integer dot max values is out. Processing, why processing is not there? Thread dot start, this is not a daemon thread, it's ending also. What's the okay, interrupting thread now. Okay, I haven't even provided any task to the thread. Shit, we have to provide task also, right, to the thread. Empty task we are trying to run, right? Now it will. Okay, interrupt thread now. Processing for integer dot max value. Why only one time processing? And it ended as well. All right, I equals to 0 while less integer dot max I plus plus random and this. Okay, anyone any idea why it's not moving on loop? Okay, task we have provided, task we have started.
Semicolon you put, I think, of in the for loop. Ending.
Okay, yes, my bad. Let's run it again. So now it's keep on processing it. Cool. So let's stop all this too. Now run this again and try to interrupt it. So you will see, if running thread we try to interrupt, so what will happen? Nothing, right? It's keep on moving on.
Okay.
Wait, let me do plus I so that it will be more visible. It's keep on moving, right?
Okay.
We have long passed it, because the thing is, the thread is already awake, right? So if you, I mean, we have already covered this thing, right? If someone is already awake and you will come, hey, wake up, he will say kaam kar apna, right? I think this is the example that I have provided the last time. So that's the same thing, but what if okay, what if a thread is sleeping? It's obvious, right? If this thread is sleeping, what will happen? If I'll do thread dot sleep and then 30 seconds. Oh shit, it's a runnable, I need to handle it. Cool, no worries. What will happen if I run this now? It will be interrupted, right? Interrupted, right? Because it was sleeping. And someone, he want to sleep for a long time, but someone comes, he want to sleep for 30 seconds. Yes, but someone comes and wake him up, right? And now it does not know, any implementation does not know if someone wakes him up before the 30 seconds. So that should be in the catch, but we haven't completed it. So this is the, if someone is wake, you want to wake it again, then nothing will happen. If someone is dead, you want to wake him again, then nothing will happen, right? The thread should be alive at least. And then, but if someone is sleeping, you wake him up, then if you want to sleep for 10 hours, then he don't know what to do, right? Same thing happens with us also. But what if, okay, we can add thread of sleep again. Okay, we can convert this into callable so that we don't have to handle anything. And then but the thing is, let's make it of integer, and instead of void we can make it integer, return 1, and then now I don't need to handle anything. Even I can even remove this, right? I can just simply return thread.sleep here now. Thread.sleep end of 50 seconds, right? Now okay, task, okay, thread don't work with it. All right, but I need thread. Okay, my bad. So I have to make it runnable again with the try and catch. Okay, 30 seconds, and again we try and catch. All right, now I'm going to create a new thread, right? Now this thread will be the waiting thread. Thread waiting thread equals to new thread. Okay, but I need to write a code in such a way that it requires a resource. All right, I can do it, no worries. So this will be the waiting thread, and I will be waiting thread dot start. All right, so waiting thread dot start. Now what will happen if I come here? Let's write a resource int static, my bad, static int, and let's say lock equals to 1, and I'll say that over here synchronize lock, and okay, static, and just open over here, and for loop where it's ending here. So cool, and object and int, okay, my bad, yes, integer, okay, let's provide an object also can work. Object equals to new object. Instead of object, let's say integer. It's better, an integer dot pass integer. Okay, let's say one will also work, no worries. And now the thing is, thread 1 will come, and let's write which thread has come. Thread dot current thread dot get name has come to get lock, and only one will go inside this, right? This out. Okay, now we don't have to run this thing, right, multiple times, because we are already using thread dot this thing. So processing, but who's processing? This thread is processing. We need to make sure that this thread is processing is printed. All right, not twice, only single printed. Cool, visible. Is this example clear? Try, catch, and synchronized don't require this thing. Cool. So what will happen, what's going to happen, we have two threads, thread and a waiting thread, right? And though both I have started, so obviously thread 1 will come because I'm starting it first. So thread will come and take the lock, and it's going to take the lock for 30 seconds, right? Let's make it more, right? Multiple seconds is going to take lock. So it's going to take to process this much time. Till that time, our waiting thread will be here at line number 10, oh sorry, at line number 11, waiting for the lock, right? But this thread will take the lock, and during that time when this waiting thread will be in the waiting state, I'm going to interrupt it. Cool, visible?
Okay.
So now let's run the example. Anyone having any doubts? All right, cool. I'm moving ahead with the example. So now the thing is, interrupting thread now. Thread 0 has come to get lock. Hey, thread 0 processing. Where is the thread 1? Okay, I haven't even provided him the task. My bad. So the thread was dead, so that's why I'm trying to wake up the dead man. So thread 0 has come to get lock. Okay, I have to make sure that it's waiting also. Okay, my bad. It should be in the running state also. Thread dot sleep 2 seconds. After 2 seconds I'm going to try to wake the thread up. After 2 seconds thread dot sleep. So now let's run it again. So thread 0 has come to get the lock. Thread 0 is processing. Thread 1 is processing, right? Is in the waiting. Thread 1 has come to get the lock. It's in the waiting time area, right? And after 2 seconds I tried to interrupt, but what happened? Nothing, right? So let's reduce the time after 2 seconds. Let's say that it required, let's say 3 seconds, and okay, after 2 seconds I'm interrupting it. So let's take 10 seconds over here. All right, so thread 1 will come obviously, and then it will, okay, thread 0 will come, it will obviously take the lock. After 10 seconds it will leave the lock, but after 2 seconds I'm going to interrupt the waiting thread. So I'm running the code again. So thread 1, okay, thread 1 come to get the lock. Sleep interrupted. Who was sleeping? Okay, how one get the time? Okay, one which, okay,
There's no guarantee which thread will come first.
okay, yes, thread 1, okay, my bad. Okay, but I can make sure. Okay, thread dot, okay, I will wait for 2 seconds over here, at least 1 second. Thread dot sleep, 1 second is way too high timing, right? Thread 0 has come to get the lock. Thread 0 is processing. Thread 1 is waiting, right? And I have interrupted thread 1 already. And then thread 1 started processing, and then thread 1 get interrupted. Okay, it was trying to interrupt at this. Let me print the timing also. Plus system dot current milliseconds divided by 1000, and one more, and whenever it get interrupted, let's log also, and get thread name plus interrupted at this milliseconds. Let's run this now. Thread 1 has come to get the lock. Interrupting thread at this number. Okay, after dividing by 1000 also, no worries. And after, so the timing I wanted to interrupt is this, and it is interrupted at this. Difference in the timing is visible. Hello, am I audible?
Yeah.
And another thing, thread 1 started processing, right? Over here thread 1 started processing, and at that time, okay, one, this thing is blank. So after that it was interrupted. Yes, I'm audible?
Okay.
So thread was not interrupted until it was in the waiting state, right? let's, if I add more seconds over here, 10 milliseconds it was requiring, right, earlier on. So if I make sure that it's 20 seconds, now if we run again, so thread 1 come to lock, and at time this 17 it has interrupted the thread, right? Thread 1 has been interrupted. Thread 1 is this thread. It has been interrupted at here, right? But nothing has happened till now. It has been waiting until the thread has processed. So if I know that my thread is already doomed, right, why should I make sure that it wait in the queue, and then when it gets the lock, then I will interrupt it, and then interrupt exception will occur, and then it will end abruptly. So it makes no sense, right? If I know that my thread is doomed for good, then I should kill that thread at that particular moment only, right?
Yeah.
That thing makes more sense, right? So what can we do with this? And but the bad thing with this, for this example, we have to take the lock object itself. We cannot take some other object. So we are going to mimic this thing, and but the lock, obviously now we are going to get the lock, and the lock will allow the thread to get interrupted while in the waiting state. So where are the locks? Multi-threading locks and basics. Locks and basic, waiting for n seconds. All right, then package where lock interruptibly, or interrupt while waiting. Interrupt while waiting. So interrupt while waiting, I'm going to create a runner, obviously psvm, and okay, I need to create a resource. Okay, my bad. Resources should be resource school. Then okay, psvm, which was great. Then need to, okay, resource class will have a private final lock equals to new reentrant lock, and I don't want this lock to be fair, so there is nothing. And why it's showing error? Invalid method. Okay, my bad. Cool. Okay, so public, okay, void, okay, get resource, and over here sysout thread dot current thread dot name plus, okay, here to get resource and add plus, okay, we'll put it later on, not add, we don't require add and those things here. So over here we can do lock. Okay, so what we need to do in the example, okay, let's write some different example, and then we can change the code so that it can be interrupted. So in our task, what we need to do is simply what we were doing earlier. We were using lock, right? So lock dot lock, and then we were doing unlock, right? This is the thing that we were using, right? And over here processing, right? And it will process for thread dot sleep, let's say for 30 seconds. Clear till now? Nothing new, nothing great, right? Simple. Multiple threads would come here, but only one thread will move ahead, right? So it's in the runner. So let's create it. Okay, let's create the resource first. Resource equals to new resource, and now create a task, runnable task, and the task will be a resource and get resource, and I need to create 2 threads now. Threads, and a normal thread, new thread, and then I will submit the task, and the task dot okay start. Okay, my bad, thread dot start, and then there will be a delay, thread dot sleep of 1 second. So to make sure that thread 0 get the task first, and then the waiting thread, and the waiting thread equals to new thread, same task, and waiting thread dot start, and then let's wait for 2 seconds again, at least 1 second, that's it. Let's wait for 1 second, and the waiting thread dot interrupt. Cool, visible, and that's it. And when I put it here, get resource, let's put it inside the try catch. Okay, we don't have to. So see, the thing is, if I run this code now, okay, my bad, itne ki throws, what will happen? This is not the code that will handle the things properly, right? So thread 1 is here first, thread 0 is processing, it will process for 30 seconds, and why thread waiting thread interrupted? Okay, I haven't mentioned the waiting thread interrupted, my bad, let me write it down. Sys out waiting thread interrupted at plus system dot second that 456. Cool. So let me just copy paste it here and go to the resource and plus this. Okay, don't have to add even plus, and this plus this, and interrupted. Make sure try, let's add try and catch here, catch exception E, and just write down the entire code, paste it here, and current thread processing, not processing, interrupted at. Cool. The same example we have made from the last example. Let's run this now. We have to wait for 30 seconds. So see, thread 0 come, get the resource at this time, then 0 has started processing, thread 1 is waiting, right? And we have already interrupted the waiting thread, right? But we are, because we now know it's doomed, but we will wait for 30 seconds. We wait for it to get processed, and after, okay, I think it's been a while, 30 seconds is not get completed till now. All right, so thread has been interrupted, right? Thread 1 has been interrupted at 7:23, right? The same second that it was started processing. As soon as it started the processing, it has been interrupted, right? I'm audible?
Okay.
So now you can say that, okay, so what's the difference, right? So it makes no sense. It's the same thing that has happened earlier. The same thing has happened now, right? So what's the difference? The difference is we haven't used a method. We can take the lock, but we can take the lock interruptedly. So now if we run it, thread 1 come here and see, boom. As soon waiting thread interrupted at this, as soon as it was interrupted, exception is there, right? Visible?
Okay.
So now if I use the lock interruptedly, so now the thing that I had, my waiting thread was not even waiting. It left, right? It was waiting. It was waiting at there, right? It was waiting there, here at line number this. But the try was here. Sleep, when it was sleeping, then only the catch will work, right? And when it was here only at line number 15, then only it will get exception was thrown, right? From there only itself.
Okay.
So, oh sorry, 16, it was waiting for here, right? You can see it here also at line number 16, the exception arised because it was waiting and it was interrupted, and that's it. So the drawback of this thing, this was a drawback, right? That even though 10,000 threads were there and you interrupted 9,999 threads out of it, because one thread was working already, right? So your 9,999 threads will first going to get the lock, and then they are going to throw the exception, right? So it's going to take a while to process all those things, right? It's like a drama. First someone will cry and then someone will die. If you want to kill someone, let's kill, right? Why you are waiting for sequential man, right? Just, okay, I'll cry and die, I'll cry and die, cry and die. So those situations will happen earlier. But if you use lock interruptibly, then it can be that particular thread can be interrupted while it was in the waiting state. Clear now?
Acha, okay.
All right. So do you want to move ahead now, or we should end the session here? It's been 1.
Yeah, tomorrow we'll do it.
All right. So we can start tomorrow.